Hi everyone, this is the third video of this course. Uh, in this video, I would like to explain stellar evolution very briefly. Stellar evolution is important to make neutron stars. Let's start. Today's target is stars here in this figure, like sun. Okay, let's consider what is star. I show two astronomical objects, Sun and Earth. Sun is star and Earth is planet. What is the biggest difference between them? Let's consider. Okay, the answer is this. Sun is shining by itself. It emits photons by itself, and Earth just reflects the light from Sun. This is biggest difference. And here is the definition of stars. Star is an astronomical object, a gas sphere, that generates energy through nuclear fusions. I would like to explain these points in this video. First, let's consider astronomical gas sphere part. Star is a gas sphere, and it is gravity. So it's the self-gravity of gas sphere binds the gas. But if the force is just gravity, it should shrink. But as you know, sun is not shrinking or collapsing. So let's consider why a star does not collapse by its self-gravity. Answer is pressure of gas. Star is in forced balance between gravity and pressures. Gravity is to inner direction and pressure is to outer directions. And stars are in forced balance between gravity and pressures. Okay, let's consider what happens if gravity is stronger than pressure or pressure is stronger than gravity. Let's consider. The answer is very simple. When gravity is stronger than pressure, it shrinks. And when pressure is stronger than gravity, it expands. It's not so difficult. Just consider the direction of force, gravity, and pressures. Okay, next, let's consider the second part. Generates energy through nuclear fusions. As you know, stars and suns are shining. It emits light. But what is energy source of this light? The answer is nuclear fusion. Very simply, nuclear fusion is explained by this equation, E equal mc squared. Here, E equal energy, m is mass, and c is the speed of light. This equation shows that mass can be the energies. And this equation is consequence of Einstein's special relativity. And Hans Bethe proposed the idea that the nuclear reaction can be the energy source of stars. At the center of stars, nuclear reaction occurs. And here is an example of nuclear reactions. 4 hydrogen nuclei makes 1 helium nuclei, 1 helium-4 nuclei, and 2 positron and 2 neutrons. And the rest mass of these 1, 2, 3 objects, so rest mass of these objects is smaller than the sum of 4 hydrogen nuclei. And the deficit mass becomes energy and it is released following these equations. So like this kind of nuclear reaction, energy is emitted in this center region of stars. So we know that the energy source is nuclear reaction and nuclear reactions. Okay. So let's go back to definition. A star is astronomical sphere in force balance between gravity and pressure, and that generate energy through nuclear fusion at center region, and the energy is released. From observation, we can measure the color of stars and luminosity of stars. And many stars are in these lines. This line is called main sequence. And from theoretical point of view, we know that these main sequence stars are hydrogen burning stars. So at the center of star, hydrogen is burned, and 4 hydrogen makes 1 helium atoms, and energy is emitted through these nuclear reactions in this part. And when hydrogen runs out, when hydrogen runs out, it moves from these lines, something like here or here, here or here. And this slide shows the very simple evolution of stars in the last diagram. Stars are in force balance between pressure and gravity. And at first, hydrogen is burned at the center of stars. But when nuclear fuel, in this case, hydrogen runs out, there is no energy source for nuclear burning. Then the star just emits energy because there is no energy source. It just emits energy from gas sphere. And it means the star is cooled. And when it's cooled, the temperature decreases. And as a result, pressure also decreases. So the force balance is broken. Pressure becomes weaker than gravity and the gas sphere shrinks. Okay? But in the during the shrink of star is a kind of adiabatic compression of gas. So as a result of this compression, the center of star becomes high temperature. Okay, it's a kind of thermodynamics. And when temperature increases due to this shrink, next nuclear burning occurs. And in this case, first hydrogen is burned, and when star runs out hydrogen, it's shrink, and next helium is burned at the center of stars. And after helium runs out, Next, then it shrink again, and next carbon is burned. And star in the life of star, it continue these cycles: helium, hydrogen, carbon, neon, oxygen, silicon, ions. These nuclei are burned. Then, when this cycle ends, from nuclear physics, we know that helium is the most stable nuclei. So, iron is most stable and it cannot be the energy source for nuclear reactions. So after making ions, no further progress in nuclear fusions. Then it emits energy and temperature decreases. And at last, pressure becomes weak and gravity becomes stronger than pressures. But in the pressure, so gravity becomes stronger than pressures and it shrinks. But in this case, no other nuclear fuels. So it just shrinks. And at some time, it shrinks and emits wind. Or it just shrink and bounce. This bounce is called supernova. And after this shrink or explosion, neutron star or white dwarf or black holes are created. This is the death of usual star, and in other words, this is the death of so-called stars, but this is the birth of compact objects like neutron star, white dwarf, or black holes. And their fate is determined by its initial mass. Here is a very simple figures of their life cycle. Star is made and large star becomes red supergiant and it explodes. And in some case, neutron star is created, and in some case, black hole is created. When initial mass is small, small star is created. And after evolution, it just emits its mass by wind, and at last, white dwarf is created. Okay, here is a summary of this video. A star is sphere that shines by themselves, and the star is in force balance between gravity and pressure. And this pressure is energized by nuclear burning. After running out of all nuclear, it means once iron is created, then massive star experience supernova explosion, and as a result, neutron star can be created. Okay, here is summary of my talk. And this is the homework of this video. Please estimate the density of sun and your rest mass energy and age of sun assuming luminosity, assuming sun age assuming using these values. Okay, thank you very much.